if your slope is a negative number, it'll go pitch down. So it'll go like this. From left to right, it goes down. All right? So that's what happens if it's positive. This is what happens if it's negative. What about if it's 0? What if your slope is 0? Straight line. Well, okay, so be careful when you say straight line, because this is a straight line and this is a straight line. I think what you mean is...
It doesn't touch one of the...
Okay, so if the slope is 0, it's actually a horizontal line. Okay, it's horizontal. So it'll go like this, all right, horizontal. And then the last one is the case that we have not looked at here, which is a vertical line. And so I have a question for you. And I'm going to try, right now I'm just going to put M and then I'm going to put a question mark because I want us to kind of think about this. Look, if I'm trying to get from this point, let's say to this point, then I'm going to go up, right? Up, that's going to be positive. And then I'm going to go to the right, which is going to be positive. And that means my slope is a positive number divided by a positive number. Agreed? Up is positive, right is positive. So that means my slope is positive. Here, if I'm trying to go from this point, let's say to this point, I'm going to have to go to the right and then down, right? Or you know what, let me go it the other way. I'm going to have to go down and then to the right. So if I go down and to the right, down was negative, wasn't it? And to the right was positive. So we're going to have a negative divided by a positive number, and that's why my slope is negative. Make sense?
Yeah.
Okay, here, if I'm trying to go from here to here, what's my rise? I have no rise, okay? What's my run? What's my left and right? Well, if I go from here to here, it's going to be a positive number, right? But 0 divided by anything is 0, right? 0 divided by 4 is 0. 0 divided by 5 is 0. So your slope here is 0. Does that make sense? Now look at this one here. If I try and get from one point to the other, what's my rise here? Let's say I go from here to here. My rise would be positive, wouldn't it? And I'm going to divide that by what? My left and right. But I'm not moving left and right, am I? So I'm dividing by 0. And haven't you been told your whole life that you can't you cannot divide by 0? Right? So when you get to this very special case where you're looking at a vertical line, the slope is actually undefined. A vertical line does not have a defined slope. It's undefined. 0 slope, horizontal. Negative slope, you're pitched down. Positive slope, you're pitched up. Straight up, undefined. So just out of curiosity, if I did this line right here, what would the slope of that line be? Positive or negative? Positive, right? Which of these would have a bigger slope in terms of a number? Like let's say the slope of this one, let's just say was 3. Would that one be bigger than 3 or smaller than 3? So what I'm trying to get at is the more I pitch this line upward, is my slope getting bigger numbers or smaller numbers?
Smaller. Bigger numbers. Smaller than us.
So let's see. Maybe I need to draw this. Let me draw it this way. Okay, so let's do it this way. Okay, let's just do a simple one where I have 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, let me draw this line right here. Where I go from here, I go up 1 over 1. What's the slope of this line? Up 1 over 1. Slope of that line is 1 over 1, which is 1, right? Okay, let me draw a line that's like this. Very steep, right? Very steep. What's the slope of this line? So I have to go up 1, 2, 3, 4, 5, 6, right? Over how far to the right? 1. That's 6, right? So the steeper your line gets, the bigger the number gets. So if I had a line that was, okay, that's vertical, right? Vertical, the slope is undefined. But if I just tilt it slightly to the side like that, that's going to have a huge slope. That'll be maybe a slope is like 1,000. Up 1,000 over 1. If I go a little bit more closer to vertical, maybe it's like 1,000,000 over 1. Make sense? Mm-hmm. Now if we go this way, these numbers get smaller. So maybe like this, the slope is 1/2. Maybe it's 1/4, 1/10, 1/100th, 1/1000th. And eventually you get straight across, which is 0. And then as soon as you go past that, now you start getting negative slopes. -1/2, -1, -1, -2, -3, -4, -5, -6. Make sense? Yeah?
Yeah.
Okay. That's not that important. All you need to know is positive slope, negative slope, 0 slope, undefined slope. Those are the things you need to know. How are we doing on time? Okay, so now you know a little bit about slopes. Let's talk about two classifications of lines. Parallel lines. All right, so you've probably heard of parallel lines before. So if you were going to explain to somebody who really wasn't familiar with what parallel lines are, does someone want to volunteer to explain what parallel lines are? Lines that don't intersect. Do y'all like that definition? Mm-hmm. Two lines that do not intersect. Good, I like that. Anyone have a different alternate? No? Okay. I'm going to add just one thing to it. Two distinct lines that don't intersect. And the reason I'm saying distinct lines is because I want us to make sure we are talking about two different lines. Because what if I gave you a line and I gave you the same line? Then they would be parallel, but they would be the same line. So we want to, when we talk about two parallel lines, we want to say that they are two different lines that never intersect. So if you have two lines that don't intersect, what's another property of those lines that you could give me? Ah, yes, they have the same slopes, right? These two lines, if they're parallel, if they hit each other, then they're going to have to look something like that. But to not hit one another, they must have the same slope, right? So that's the second definition I'm going to put up here. Or I'm going to put here two distinct lines with the same slope. So let's do an example. I'm going to give you two lines, L1 and L2. So that's an L, all right? Here's your first line. Y equals 4x plus 1, and then this one is going to be negative 4x plus y equals 12. Okay, my question is, are these parallel? I heard yes already. How do you know they're parallel?
Because if you move the 4x over,
If you,
y equals.
yeah, so if you move that over. So let's understand, first of all, this one right here is the first one I gave you here. This is already in the form y equals mx plus b, isn't it? That's already in that form. So the number in front of x here is 4, and that's the slope. I'm going to put m subscript 1. That's the slope of the first line, right? The slope of the first line is 4. So m1 is 4. In order for these to be parallel, the slope of this line must also be 4. But first you have to make it look like y equals mx plus b. So you have to get this on the other side. So when you move that to the other side, you add it, and you'll get y equals 4x plus 12. Right? So they have the same slopes. This right here is the slope of our second line, and they're equal to one another. Agreed? How do I know they're distinct lines? How do I know they're not the same line, though? The y-intercepts are different. The y-intercept of this one is 1, and the y-intercept of this one is 12. So they would be drawn at different y-intercepts, but they have the same slope. Right? So the answer to this is they are parallel. All right, so I'm going to challenge you for a second. We're going to take a little detour here for a moment. Anybody here take any art classes or drawing, like art history or even art, like drawing art? You've taken some, yeah? Okay, hold on, I got to sneeze. Thank you. All right, so have y'all seen like old caveman drawings? Like on caves, you've seen the drawings? Were they pretty good? Were they pretty good at drawing?
Yeah.
You think so?
Yeah.
You think that? So you think that they draw better than you could draw, you think?
Yeah.
Yeah, me too. Me too. Well, I mean, okay, so for back then, but a lot of their figures were very like sticky figures, right? Right? I mean, almost like childish, you know? Like, and that's an exaggeration, but that's in the very beginning, as humans were trying to draw, it was very primitive, the drawing. It's gotten a lot better now, right? You can see people drawing pictures of people's faces, and it's just like, wow, it's incredible what people can do, right? Believe it or not, there's mathematics behind this, all right? So I'm going to try and illustrate with an example. I'm going to draw you a picture of a street with a couple of buildings on the side, all right? So here's my street. Here's the middle of the street, those little lines in the street. Then here's a building here to the side, a building. So can you tell which way we're looking at this from?
Bird's eye view?
It's almost like a bird's eye view from the top, right? Notice that everything in this picture follows the rules of geometry that we were just talking about. Parallel lines. These two lines are parallel, right? That line's parallel. Those lines are you know, that's parallel to that. These lines are parallel, right? Everything's kind of, I'm using the rules to draw something, and it's not terrible, but it's not great, right? So now, how many of you have ever done perspective drawings? Has anyone ever done a perspective drawing? No? So when you do perspective drawing, what you do is you start with the horizon, and then you have this point right here, which we call a vanishing point. And the rule here is that all parallel lines do intersect. It's the opposite of what you just gave me as the definition. So watch. Every line that's parallel here has to eventually get to that point. So let me start with these two lines right here, these two street lines. Those two street lines have to go to that point, right? And then the line in the middle, this dotted line, also has to get there, right? And then the edges of these buildings also have to get there. So I'm going to just go a little faster because I've done this before. So not doing good there. I think you get the idea here. It's a very rough sketch there, okay? Better than that? This is more three-dimensional on a flat sheet of paper, right? So now you get this feeling as if the picture is like what you would see with your eye, right? Agree? It's like more like what you would see. And so what we realize is that there is a certain geometry that we use everyday mathematics. The one that, when I asked you the definition of parallel, you said two lines do not intersect, and everyone here said yes, thumbs up, agreed. This is called Euclidean geometry, and we use this all the time. All the math that we do is pretty much Euclidean. But there are other parts of our existence that require different types of geometry. This is called perspective geometry, and it is used when you're trying to trick your eyeballs into seeing three-dimensional space on a flat sheet of paper. You must make parallel lines intersect in order for that to work. Understand? Okay. So this is just kind of a FYI. There's more than one type of geometry out there. And that's perfect time to take a break. All right. So let's it's 12:15. Let's come back. Let's come back at 12:30. I've got to take care of something. So 12:30, 15-minute break. Any objections? Okay. Excuse me. All right, back to business here. All right, so we just talked about parallel lines. So parallel is that we need the slopes of the two lines to be equal to one another, right? All right, so the other type of lines we want to look at are perpendicular. So how would you explain to somebody what two lines that are perpendicular are? They intersect, yes. That's not quite enough though, because these two lines intersect one another. So it's something else, more than just intersecting. At 90 degrees, at a right angle. Okay, so two lines that have to hit at a right angle. So they're going to look like this. One line does that, the other line comes through and hits like this, so that we get this box 90-degree angle there. So what do you think the relationship between the slopes are? I mean, they're not equal anymore, right? Do you think there is a relationship between the slopes? This one is this way. If that one's positive, the other one's going to have to be negative, right? So is it this, you think? Are they just opposites? Well, it turns out no. All right, that would be nice if that were the case, but that's not the case. What it is it has to be the opposite in sign, but it also has to be the reciprocal. Okay, so that can be confusing. So let me give you a specific example. Like over here, if the slope of one of the lines was 4, the slope of the other line would have to be 4 also. That's straightforward. But over here, if the slope of this line was 4, the slope of this line would have to be negative, and then that fraction flipped over. So 1 over 4. Does that make sense? Yeah. I can give you another example. If the slope of one of the lines was negative 3/2, what would the slope of a line perpendicular to this be? So it'd have to be the opposite of the sign. Since this one's negative, this one would have to be positive, right? 2 over 3. Yeah, 2/3. Okay? So that's the relationship. Let's do a problem where I give you two lines again. So L1, let's say this one is 3x minus 5y equals, let's say 10. And then L2, let's say this one is 5x minus 3y equals 12. So my question to you there is, are those lines parallel? Are they perpendicular, or neither? Right? Because just because I give you two lines doesn't mean they have to be parallel or perpendicular. They could be neither one. So in the case that it's neither one, we call those lines skew. So the question is, are these parallel, perpendicular, I'm just going to put perp, or skew? All right, so what are we going to have to do to check this? Miranda? Where's Miranda? Miranda, what are we going to have to do to check that, which of these three cases we have? Uh-huh. That's right. We have to put both of these lines in y equals mx plus b. Make it look like that form so we can identify the slope. And then we just compare them. Right? So let's work with this one first. If I try and solve for y, what would be my first step to solving for y here? Move the 3x to the other side. So I'm not showing these steps as much anymore. Is that okay with you all? I'm subtracting 3x, subtracting 3x. Next step, divide by -5. So divide this by -5, we get y. What happens when I divide that by -5? Positive 3 over 5, because negative over negative would be positive. And then divide that by -5, -2. Okay? So, Miranda, what's the slope of L1? 3 over 5. So this is the slope of our first line. Okay, good. Is it Devon? Devon? No? Victor?
Here.
Victor. Okay, Victor. So how about on the second line? What would be your first step to get it to look like y equals mx plus b?
You would move the 5x.
Move 5x, so it would be -3y equals what?
Negative 5x.
Negative 5x plus 12. Then what?
It would divide
By -3. Okay, so -3 here, that would give us y. -3 here would give us what?
negative 5 over -3.
So negative over negative would be positive again, so 5 over 3x. And then this one divided by -3,
Negative 4.
-4. Okay, so what is the slope of this line?
5 over
5 over 3. That's the slope of your second line. All right, so we get to start over again. Luke.
Sir.
So are these lines parallel, Luke?
No.
No. Okay, because these aren't the same, right? Are they perpendicular?
No.
No. This one is these two, like this one is that one flipped over, right? But they're not different in sign. Like we would need one of these to be negative, wouldn't we? And so they're not perpendicular, which means they're skew. All right? So no, no, yes. Understand how that works? Okay. All right, let me see where we are here in the notes. We'll do that in a second. Parallel and perpendicular. So here's the where they give you two lines they ask you. Oh, you can tell. Look at this one right here. Can you tell if those lines are parallel, perpendicular, or skew? These are perpendicular. Slope of this one is -2/5, right? And this one is 5 over 2. So that's perpendicular. All right. All right. So far, everything that we've done up to this point, I've given you the equation, and we've either graphed the lines, right? Or I've given you the equation, I've asked you if they're parallel or perpendicular or skew, right? But I've always provided you the equation of the line. Now we're going to do this a little bit different. I'm going to give you 2 points on the line, and I want you to give me the equation. All right, so how do we do that? We need a formula for this. So given 2 points, I'm going to put above here, finding the equation of a line. All right, finding the equation of a line. Given 2 points, we first find the slope of the line. Okay, so if someone gives us 2 points, I'm going to draw a picture that goes with this. They give us 2 points that lie on a line, and we want to know the equation of that line. The way we do it is as follows. We label this point, let's label it, we call it x1, y1. So that's the x and y coordinates of the first point. And then this one we'll label it x2, y2, which will be the x and y coordinates of the second point. The first step to finding the equation is to find the slope, which is basically your rise divided by your run. So the rise between these 2 points is the difference of the y coordinates. It's you know, how much is this y coordinate changing as I go from here to here? So the slope formula is that the slope will always be, let's write it down, rise over run, which for us is the difference of the y coordinates It's this y coordinate minus that y coordinate, divided by the run, which is the left and right, which is the difference of the x coordinates. So x2 minus x1. And this is a formula that you will need. But all that gives us is what? The slope, okay? The next thing that we need to find is the equation. And the equation, we use this formula. Y minus y1 equals m times x minus x1. And this is called the point slope formula. I'm off the camera there, but it's called the point slope formula. They call it the point slope formula because in order to use the formula, you need two things. You need a point. So in this case, it's the x1, y1. So you need one point, and then you need the slope m, which we get from that formula right there. So as long as you can calculate the slope and use one of these points, we can find the equation of a line. All right, so you ready to do an example? I'm going to give you 2 points. We're going to find the equation of the line through those 2 points. So let's do this one. Find the equation of the line that goes through -2, 5, and 8, -10. Right there. So I've given you 2 points, right? Given you two points. Oops. Timothy? Where's Timothy? Timothy here? Timothy? So the first step would be to find what here?
To find slope.
Slope. Okay, so my slope, maybe I should label these. Why don't I call these so we all do the same calculations? I call this one x1, y1, this one x2, y2. Is that all right, Timothy?
Yep.
Okay, so first step is I'm going to find the slope, and that will be, you tell me what I need to write in here.
Y2 minus y1.
Y2, which would be?
It's going to be -10.
-10. Take away.
+2, +5. Oh no, -5.
-5, okay. So that's y2, take away 5, and then over
It's going to be 8.
8, and then take away what?
-2.
-2. So be real careful with that. You're going to be, the formula is a minus. You have minuses here. But that's a negative number, so you're going to have to subtract a negative. So what is the top, Timothy?
It's going to be 5.
I owe you $10. I owe you 5. So
Oh, -15.
-15 over, and this is minus and minus become plus, right?
10.
10. And then let's reduce that. 5 goes into both of those, right? So -3 over 2. Okay, there's the slope of our line. Okay. Now, we're not done. Brianna? Brianna, I already called you, right? Okay, I called both of you. I won't call you again today.
Okay.
Laura K., I called you. Brianna. Let's see. Jameson. Yeah, you're on standby today. Gia? Gia. Okay, Gia. I forgot what I'm doing, Gia. Second step, right? Use the formula. Y minus y1 equals m times x minus x1. That's in parentheses. So help me fill this in now. What am I going to write in here? I heard you say -3 over 2, so let's write this out from left to right. So first, y, right? That just stays y. Minus, Gio, what comes next? I'm doing minus y1, so what is that for us? -5, okay. And then equals,
And that's for your fraction.
that's where you get the -3 halves right there. That's this. Parentheses, and then the x will stay x, and then subtract what? Negative 2, so minus negative 2. There we go. Okay, so that's the equation of the line, but it doesn't look very pretty yet, right? So let me clean this up. Y minus 5 equals negative 3 over 2 times x plus 2. So changing that minus minus to plus. That better? Now the next step, what I'm going to try and do here is I'm going to try and work this out until I get it to look like this. Okay, I'm going to try and get it into slope-intercept form, which means I'm going to try and solve for y. But I also don't want these parentheses here because this doesn't have any parentheses in it. So the next step would be to multiply this through, distribute it through. So David, where's David? No, David? David? No? Anissa? Anissa? I think I'm saying that right. Anissa? No? Danny? It did seem kind of skimming here today, didn't it? Dyson? Marcus? All right, Marcus, you're up. I just wanted to know, Marcus, what would happen if you distribute that negative 3 halves through?
That would be negative 3 half x
Uh-huh.
plus
Good.
getting negative 3.
Negative 3, good. So when you distribute this second multiplication, you're doing negative 3 halves times positive 2 over 1, right? That's what this is. When you do that, it's negative 6 over 2, right? And that's negative 3. Okay, almost there. Nivini? No? Aaron? Aaron Black? I've already called you. Gabriella, I think I called, right? Resteem. There you go, I haven't called you, right?
So we can do is
What's our last step? We're almost there.
Yeah, we're gonna take 5. We're gonna add 5.
Add 5, there you go. Add 5 to both sides. And those two we can put together, right? So those will cancel, and so, yep, we're there. Final answers here. Y equals, go ahead.
y equals minus 3 over 2 times
X, right?
and
Plus 2, there you go. Okay, so there's the equation of that line. If you graph that line, it should go through both of these points. All right? Do you believe it does? Do you believe we did it right? I think we did, but let me just check something real quick. I'm going to draw something really fast here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I were asked to graph this line right now, this looks like y equals mx plus b, right? So I'd start out at 2, 1, 2, and then from that point I would go where? Down 3, 1, 2, 3, into the right 2, and I would draw a line through here. Okay. All right, so what points are supposed to be on here? Negative 2, 5. Negative 2, 1, 2, 1, 2, 3, 4, 5. It's not perfect, okay, obviously I did. But do you believe that that point's there? Okay, and then 8, negative 10. 1, 2, 3, 4, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's close enough, right? I would be concerned if like I had a point over here, right? Okay. So that equation represents the line that goes through those 2 points. Yeah? Yes? Question?
Well, yeah.
Go ahead.
I figured it out.
Okay, you're
What
good?
I'm saying doesn't matter because it's negative whether you go up or down first or left or right.
That's a great question. It's a great question. Because I think I told you that what's being asked here is that when we look at that, you can look at that as negative 3 over 2, but I already told you that you can look at that as 3 over negative 2, right? Like it doesn't matter where your negative is. So would we get the same line? Let's just see. We started out at 2, didn't we? We went down 3 over 2.
Okay.
Okay, could we draw the same line if we use this instead? So start at the same point, this time go what? Up 3, 1, 2, 3, and this time left 2. Same line. Now it's going to be 2 different points, but it's the same line. All right, so it's actually good that it works out that way. I should have mentioned that earlier, I think. All right, how about this? Find the equation of the line. You ready for this? Find the equation of the line parallel to y equals negative 5x plus 3 and through the point 4, negative 7. Now I'm kind of going out on a limb here. See how this goes. Is Elizabeth here? Elizabeth? All right. We're trying to find the equation of a line, right? Okay. I've only shown you how to find the equation of a line if I give you 2 points. That's what we just did. But when we did that, we eventually came down to this formula, which was the all-important point-slope formula, right? And I said it was called the point-slope formula because all you need in order to use it is what? A point on your line and the slope of the line, right? So I'm asking you over here, Elizabeth, to find the equation of some line, all right, that's parallel to this line. So what does that mean? If I'm telling you I'm parallel to this line, how is our line related to this line? What do we have in common? The m, the slope, is going to be what? Negative 5. Right? So I know this much about the line already. The slope of the line we're looking for has a slope of negative 5. Right? So I know the slope. Right? Do I have a point, though, on my line? Well, I tell you, you have to go through this point, right? So I'm giving you a point, and then you're kind of pulling the slope from this line. So over here, you have y minus what?
Minus 5x.
Oh, nope.
No, 7.
7, good. Okay, so this is our x1 and y1 here.
Yes.
All right, so y minus y1 equals the slope, which you said is the same. Yeah, negative 5, and then
X will be X.
uh-huh.
Then minus the 4.
4, there you go. Okay, that's it, right? That's it. And then you would have to, let's clean it up. Y plus 7, because minus minus is plus. Let's distribute here. This is going to give us negative 5x plus 20, because negative times negative is positive, right? And then we would subtract 7 on both sides. So if I subtract 7 from 20, I get 13. So this right here is the equation of the line that is parallel to this line, but goes through this point. So if I graph these, if I graph this line and that line, they should be parallel, but this one over here should go through that point. This one won't. Does that make sense? All right. I don't have any other colors in here. There's some, let me go grab one of these. Purple and red. What's that red one? I doubt these work. So who's the lucky one? Let's see. Jared, where's Jared? 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 You know, y'all are welcome to move your tables back, you know, if you feel like you're like this, like at the IMAX, you know? It's probably a little annoying. Remember, the classroom is normally set up, most of the instructors use that board. I'm the only one who uses this board. So when y'all come in, feel free to back yourselves up a little bit, all right? Jared, I'm going to change the problem, and I'm going to say perpendicular here instead. So what would change, Jared, if the problem said find the equation of the line perpendicular to that line, but still through this point?
The slope would have to be like the reciprocal?
Yes. Yeah, so the only difference, we would still use the same y1, the same x1, right? This, though, would not be -5. It would be
1 over 5?
1 over 5, 1/5. Do you all see that? And then we would distribute 1/5 through and then do the same thing. All right? Yes?
You basically just put the slope over here from the beginning of the problem.
Well, because we are told we're supposed to be perpendicular to this line, right? So if we're going to be perpendicular, we're not using the same slope anymore. We're going to use the opposite sign and flipped over for our slope. Make sense?
And we use the same formula.
Everything, yeah, the same formula, point slope formula. So this is like the master formula. If you have a point and a slope, you can always get the equation of line using this. All right? Yes?
So since it's a -5 and you're flipping it, it doesn't change, it changes the negative to a positive, right?
No, that's what perpendicular. Perpendicular will always be flipped and change the sign. The flipping isn't what changes the sign. It's just that perpendicular you have to change the sign, like you just always do. Okay? So do you all want me to work through that one? And let me do it, because that one has a fraction in it. So this would change. Let me just write it down here. I'm going to go off this line right here. We'll have y plus 7 equals, now it's going to be 1/5 in front of x minus 4, like that, right? So that's the only difference between this problem and the previous one. When we distribute through, unfortunately for you, you're going to get fractions. You're going to have 1/5 x, and then minus 1/5 times 4 is 4/5, right? Because you multiply 1/5 times 4 over 1, so you get, or -4. So, you all okay with that? And now you subtract 7. So this is the part that I think is going to be a little bit messy. When we subtract 7 on both sides.
It's raining.
That's right.
Yeah.
Okay. All right, so minus 7, minus 7. So I'm going to have y equals 1/5 x minus 4/5 minus 7. All right, that's what I'm really trying to do.
Mm-hmm.
So when you do this part right here, you might have to do that on the side. Minus 4/5 minus 7 over 1. You have to get a common denominator, right? Or you can do that cross thingy, whichever way you want to do it. I'm going to do the cross thingy. I'm going to multiply here. I get -4. I'm going to multiply here. I get 35, but I'm subtracting, so minus 35. And then across the bottom, 5 times 1 is 5. So -39 over 5. So that part right there, we've done this. I understand it still is going to take a little bit of scratch work on the side to do it, but we've done this. So I think we're at a final answer here. Y is equal to 1/5 x minus 39 over 5. Does someone have a calculator? Yeah? Someone have a calculator ready? I'm going to go get something over here real quick. Boy, this thing's heavier than it looks. I've never used one of these. I've been teaching for a very, very long time, and I've never actually gone and grabbed this and used it. Let's see if it even works. Yeah, it's probably not going to work. All right, I'm going to try and draw this. Let's see here. So I'm going to graph that line first. So where do I start to graph this line? 3 up, right? 1, 2, 3, okay? And then to get to another point, I'm using the slope -5, which is the same as -5 over 1, right? Remember, rise over run, right? So 1, 2, 3, 4, 5 down, 1 to the right, okay? You mind just You can stay off camera, but you mind just holding that? Yeah, real quick. I just need my straight edge here.